Okay, so, and this is the last little bit, the directional derivative. I'll just get this going. Okay, so find the directional derivative of that function at the point 213 in the direction of 342. So the first thing we need to do is find out the unit vector, because this isn't a unit vector. So that's number one, the unit vector. And the unit vector is basically Pythagoras' theorem. So in this case, it is just the square root of the 3 squared plus 4 squared plus 2 squared. Probably wouldn't get it something that large numbers over here, but I just thought I'd use those numbers to make it more noticeable, I guess. 4 squared that's 25 plus, so this is the square root of 29. So that is our unit vector, or the vector is, the unit vector is really 3 over root 29, 4 over root 29, 2 over root 29. So that's our unit vector in that direction, in the direction of that vector. The next thing we really need to look at is our gradient function, or the derivatives of f in the direction of x, y, and z. So we're going to look at f of x, f of y, and f of z. And in this case, that is going to equal, the derivative of x is going to be 2x plus 2y. The derivative of y is going to be 2x plus 2zy. And the derivative of z is just going to be y squared. Okay, so now if we're looking at the directional derivative is going to be a combination of these two things. The directional derivative is going to be a combination of these two things. So what we're going to have is 3 over root 29 times 2x plus 2y plus 4 over root 29 of 2x plus 2zy plus 2 root 29 outside of y squared. Okay, so that is the directional derivative. If we wanted to actually find this is the directional derivative. This is exactly what we're after, the directional derivative. Now we want it at our point of 213. So at 213, what is the value of this directional derivative? It's going to be 3 over root 29 outside of 6 plus 4 over root 29. What's this going to be? 4. 6 is 10 plus 2 root 29 over y squared, which is just 1. And we could figure out what that is. What is it? You know, it's 18, 40, 18 and 2 is 20 plus 40, 60 over root 29. Okay, and that is the directional derivative at our point. So there's the 3 steps. Basically, we find the unit vector, which is just Pythagoras. We find the gradient function in terms of f of x, f of y, and f of z. And then we substitute that, we make this directional derivative by multiplying this by this. And then we're looking at what happens at our point. Okay, thanks.